All right, ladies and gentlemen, today's lesson is converting hexadecimal to binary and vice versa, which means converting binary to hexadecimal. So here is some review. Hexadecimal is base 16 because it uses 16 symbols to represent any number. Those numbers are 0 through 9, and it also uses the letters A through F, where A is 10 and F is 15. Now binary is base 2, and binary only uses 2 symbols, and those are 1 and 0. Now converting hexadecimal to binary is easy. Let me show you how. But first you need to understand that a set of 4 binary bits, or binary digits, can be used to represent all 16 of the hexadecimal digits. So let me give you an example of what I mean here. Using 4 binary digits, we could represent any hex value. So 0000 is 0 in hex. 0001 in binary is 1 in hex. And you'll see I'll go down the line, and I'm going to stop when we get to 10. So 1010 in binary is A in hexadecimal. 1011 is B, 1100 is C, 1101 is D, 1110 is E, and lastly 1111 is F. Knowing this makes converting between hexadecimal and binary very easy. So let's look at an example of a hexadecimal number. All right, I'm going to use 2F. Now I'm going to temporarily separate each digit of this hexadecimal number, so I'm going to put a big line in between them. And now I'm using 4 binary bits to represent the 2, and I'm using 4 binary bits to represent the F. Okay, notice that I'm stopping at 2 to the 3rd power on each of these. Temporarily. Hear me out. I'll show you why. We're going to use binary now to represent each of these hexadecimal digits. So the 2 is 0, 0, 1, 0, okay, because there's a 1 in the 2's place. And the F is 15, or 1, 1, 1, 1, because 8 plus 4 plus 2 plus 1 is equal to 15. So now I'm going to combine the numbers back together again, and I'm going to treat the binary number as a whole binary number. So we have a 1 in the 1's place, 1 in the 2's place, 1 in the 4's, and 1 in the 8's. Nothing in the 16ths, but there is a 1 in the 32nds position, and then nothing to the left of that. So the binary number is 101111. 2F in hexadecimal is equal to 101111 in binary. This also makes converting from hexadecimal to decimal, or base 10, very easy, okay? Because once we have the binary number, we can solve for decimal the same way we've been doing. So we have 1 in the 32nds, 8s, 4s, 2s, and 1s. If we add those together, we get 47. All right, here's another example. I'm just going to do this one on the fly. Let's take another hexadecimal number. Let's just say 4A, F. I'm going to split those up, okay, into 4 binary digits or bits each. This is my 1s, 2s, 4s, and 8s. I'll do the same here. 1, 2, 4, 8. 1, 2, 4, and 8. Okay, so 4AF. Let's solve now. It'd be 0, 1, 0, 0. 10 is a 1, 0, 1, 0. And F, or 15, is 1, 1, 1, 1. So 4AF is 1, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1 in binary. Now, let's go the other way. Let's solve from binary to hexadecimal. Okay, so if you're wondering how to do this, it's just as easy as what you did. And let's look at this example of a regular old binary number, 1, 0, 1, 0, 0, 0, 0, 1. If we split each group into 4 bits, again, so there's a group, there's another group, we solve for them individually. So 1, 0, 1, 0 is a 10, or we don't use 10 in hexadecimal, so we have to use A. And 0, 0, 0, 1 is the equivalent of 1 because there's a 1 in the ones place. So this binary number is equal to A1 in hexadecimal. So something to note here is that if you're trying to convert a binary number that doesn't have enough zeros, what you can do is you can add insignificant leading zeros to the left. Let me explain what I mean by that. Okay? Take, for example, our binary number 10110. Okay, I have to split these up into groups of 4. So that's going to be our first hexadecimal digit. Now there's this lone 1. Okay, that's in the ones place. And if it helps you, you could add insignificant zeros, leading zeros to the left of that number. Now we're going to solve for this individually. Okay, so this is 1 because that's the 2 to the 0 place. And if we think that this is the 1s, 2s, 4s, and 8s place, it's 4 plus 2 or 6. So the answer is 16. Alright, so here's your chance to show me that you understand what I'm talking about in this lecture by doing some of your own problems. Make sure you guys are showing your work on a separate piece of paper. And let me know if you have any questions. This is Westfall, signing out. Peace.